Good evening, everyone. Can anyone please confirm if I'm audible?
Sir, you are audible.
Yes, sir.
Okay, that's great. So, good evening, everyone. As we continue to expand the horizons of Veritas Vanguard, today we are going truly international. It is my absolute honor to introduce a speaker joining us from all the way from Beirut, Lebanon, Miss Yoanna Attieh. Miss Yoanna is a dynamic force in the field of forensic education and emergency response. She currently serves as a forensic science instructor at the prestigious Attieh Academy and is also a key faculty member here at Forensic Fusion. Her expertise in forensic ballistics is not just theoretical, it is fought in the field. She underwent rigorous specialized training at the ballistics laboratory of the Lebanese military police. There, she gained hands on experience in firearm identification and trajectory analysis, the skills that she will be sharing with us today. But her profile extends beyond the lab. She is an emergency responder consultant for Kenyan Emergency Services and a trainer of trainers for the Lebanese Red Cross, where she has led teams in high pressure emergency situations for over 7 years. She holds a bachelor's in forensic science from the American University of Science and Technology and is currently pursuing a degree in law at the Lebanese University, bridging the gap between science and the courtroom. Interns, you are in for a masterclass on firearms and investigation. Please give a warm virtual welcome to Ms. Yoanna Attieh. Over to you, ma'am.
Good evening to everyone joining us from around the world. Mr. Swapnil, thank you so much for having me. My name is Yoanna Attieh, and it's an honor to be with you guys today for this international webinar on forensic ballistics. Well, I'm a forensic scientist and an aspiring legal professional, and throughout this session, I'll be guiding you through one of the most fascinating and the crucial disciplines within forensic science, which is the study of firearms and the related evidence. Just a second. Am I audible, guys?
Yes, ma'am.
Okay. So I want you to know that forensic ballistics bridges the gap between science and justice. It allows investigators and experts to reconstruct shooting incident and identifying weapons and ultimately reveal the truth hidden within ballistic evidence. So whether you come from a background in law enforcement, medicine, or forensic science, or whether you are simply passionate about criminal investigation, guys, this session will give you a structured and practical understanding of the principles that govern ballistic analysis. Give me a few seconds in order to share my screen. Okay, can you see the slide?
Yes, ma'am.
Yes, ma'am.
Ma'am. All right. So before we start, let's go through our main objectives for today's session. So by the end of this webinar, guys, you will be able to list and explain the areas of ballistics and understand how each one contributes to firearm examination. And you will identify the different categories of muzzle ranges. You will classify and recognize bullet injuries, define and calculate the angle of impact, and determine the direction of projectile travel. You will be able also to detect and interpret bullet defects, explain the methods of collecting GSR or gunshot residue. You will be able to compare bullets and cartridges under comparison microscope, in order to link evidence to specific firearms. And finally, you will determine the origin and manufacturing details of a firearm, including the restoration of erased serial number. Each of these objectives represents an essential step in the forensic investigation of shooting incidents, from the moment a shot is fired to the point where scientific evidence can stand in court. So it's really important for you all to know that each firearm is unique, just like fingerprints, guys. So you won't find two similar or identical firearms. In forensic ballistics, it's generally divided into four major areas, each focusing on a specific phase in the field of bullet from the moment it's fired until it reaches its target. So the first area is internal ballistics, which deals with everything that happens inside the firearm, from the instant the trigger is pulled until the bullet exits the barrel. It involves also the study or studying the firing mechanism, the ignition of the propellant, and the pressure generated within the chamber. The second area, guys, is external ballistics, which focuses here on the bullet's flight after leaving the barrel. This includes studying trajectory, velocity, stability, and even the environmental factors such as air resistance, gravity, and wind that can really influence the projectile's path. The third area is terminal ballistics, which examines what happens when the bullet strikes a target, whether it's a human body or a wall or any other surface. This helps here in understanding the wound patterns, the penetration, and the energy transfer. Finally, we have the wound ballistics, and I want you to know, guys, this is a sub branch of terminal ballistics. The wound ballistics here focuses especially on the effect of the projectile on human tissues and is crucial in medical and forensic examinations. So together, these areas allow forensic scientists to reconstruct events, linking bullets, weapons, and wounds to provide a clear scientific narrative of what happened during a shooting. And this is really, really important. So it's really important that we have so many types of firearms, including handguns like the Beretta M9, the rifles like the M16, the FAMAS, and so on. We have the shotguns like the pump action. We have the automatic firearm like the M249. So, as you know, the handguns has a specific anatomy, and it's really crucial to understand the anatomy in order to really understand how a gun function, how the bullet will leave the barrel and hit and the cartridge case. We have the primer, we have the powder, the case. We have some imprint left on the rim of the cartridge, and we're going to talk about them in details. Okay, just a second, guys. What happened here? Guys, are you able to see slide number 7?
Yes, ma'am.
All right. So, Mr. Swapnil, I think it's from your side. Everyone is able to see the slide number 7.
Yes, sorry to interrupt you, ma'am. I think it just went directly from the first slide to the seventh slide at my place. So maybe some network issues.
Yeah, I can understand. It's all right. It's all right. So going back to our topic, these marks left on the rim or even left on the bullet itself will help the forensic ballistic expert to know whether the bullet left a specific gun or maybe it refers to any other gun. We're going to talk about them in details in a few, guys. So, as you can see, the barrel, we have two types of a barrel. We have the smooth bore in which you cannot find any land and grooves. Okay, I'll draw something here. Okay, so as you can see, guys, we have the land and the grooves. These land and the grooves helps um, in if you want to say they help in defining or stabilizing the trajectory of the bullet, and they leave some marks on the bullet itself. So later on, when we compare them under the microscope, the comparison microscope, we can notice if this bullet left a certain gun or belongs to another gun. Okay, the second type is the smooth bore, where you cannot find any lands and grooves, even though you will find some striations, which are some marks left on the bullet, in order to compare them under the comparison microscope. Now, talking about internal ballistics, guys, this field examines the physical and chemical processes that occur inside the firearm during firing. Okay, so when a trigger is pulled, the firing pin strikes the primer, causing it to ignite. So this ignition sets off a rapid combustion of the gunpowder, producing a high pressure gases that push the bullet down the barrel. So during this process, the firearm and ammunition behave as closed system governed by a thermodynamic and mechanical principles. So by understanding these reactions, this helps experts determine whether a weapon is functioning correctly or whether it has been modified or even misfire occurred. So in forensic investigations here, internal ballistics can explain why certain residues form, why barrel marks differ, and how each weapon leaves unique microscopic signatures on bullets and cartridge cases. So I want you to have a look on this video. Please try as much as you can to focus on the mechanism of internal ballistics. And yes, let's have a look.
This animation in order to explain how firearms function in a very basic, clear way, which requires no previous knowledge. The firearm used as the model, a 1911 semi-auto handgun, will be displayed with only some essential internal parts for the sake of simplicity and clarity. This is an individual unit of ammunition, the cartridge. It is loaded into the magazine, which contains a follower and a spring that keep the cartridges under tension. The magazine is designed so that the cartridges can only be pushed out forwards. The spring cannot push them straight out of the magazine. When pulling the slide back, it cocks the hammer. Upon releasing it, the recoil spring snaps the slide back forwards, which on its way grabs the cartridge and pushes it into the chamber of the barrel. When the trigger is pulled, the hammer drops and strikes the firing pin, pushing it forward. The cartridge consists of a casing, which contains the bullet, the powder, and the primer. When the primer is hit by the firing pin, a chemical reaction inside causes a small explosion which ignites the powder. The powder burns rapidly, which increases the pressure within the enclosed cartridge dramatically. The resulting force propels the bullet, while equal force also goes in the opposite direction, pushing the slide back, which ejects the spent casing and cycles the next cartridge.
Well, were you able to watch the video, guys? Was it clear?
Yes.
All right, here another
This
one.
animation in order to explain how
Here another video, and kindly please focus on every single mechanism happening in this video.
This tiny object holds immense power. A bullet consists of several crucial components that work together to make it function. First, we have the bullet itself, also known as the projectile. It's typically made of lead or a lead alloy, designed to be aerodynamic and penetrate targets effectively. Next, we have the casing, which houses the bullet. It's usually made of brass or steel and serves as a container for the other components. The casing also provides a seal to prevent gas leakage. Now let's talk about the propellant. This is a chemical mixture, commonly gunpowder, located inside the casing. When ignited, it rapidly burns, producing high-pressure gases that propel the bullet out of the firearm. When the trigger is pulled, it initiates a series of actions. The firing pin strikes the primer, which is a small explosive located in the base of the casing. The primer ignites, creating a spark that sets off the propellant. As the propellant burns, high-pressure gases rapidly build up behind the bullet, forcing it down the gun barrel. Once the pressure reaches its peak, the bullet is propelled forward, exiting the barrel at high velocity.
Okay, were you able to watch the video?
Yes, ma'am.
Yes.
Ma'am.
Yes, ma'am.
So let's summarize what you just watched. Here we're talking about three key phases. We have the lock time, we have the ignition time, and the barrel time. The lock time, guys, is the interval between the moment the trigger is pulled and the firing pin striking the primer. This is usually measured in milliseconds, but is important in determining the firearm's responsiveness, okay? The ignition time here is the period between the primer strike and the start of powder combustion due to a nitroglycerin substance or any other chemical. This depends on the primer composition, the quality of the propellant, and the environmental condition, okay? And finally, we have the barrel time, which refers to the duration the bullet spends traveling down the barrel until it exits the muzzle. The barrel's here length, diameter, and rifling pattern all influence this phase. So understanding these three stages is very crucial for determining a weapon's performance and for identifying malfunctions or irregular firing patterns in forensic analysis. Okay?
this animation in this
Now, moving forward, we're going to talk about a special consideration in the phenomena of internal ballistics, guys. Here, several phenomena occur during internal ballistics that directly influence the projectile's behavior and the residues left behind. So, as we just mentioned, this include ignition, combustion of propellants, and the influence of barrel length in addition or besides the atmospheric conditions such as the temperature and the humidity. And when the primer ignites, it's really important that the propellant grains begin to burn rapidly, generating expanding gases, just like you saw in the video. The geometry of the gunpowder, whether it's tubular or spherical or flake shape, controls the burn rate and hence the pressure curve inside the barrel itself. The pressure measurement here is another vital aspect, and it's really important to take into consideration the pressure measurement here, because excessive pressure may cause a weapon to malfunction or even explode, guys, and this is very risky, while low pressure may result in incomplete combustion and reduced projectile velocity. So the balance between the pressure, temperature, and combustion efficiency is what defines a firearm's accuracy, reliability, and safety. So all key factors here considered in forensic firearm when testing. Okay? Now, moving forward, we're going to talk about terminal ballistics. Now that we've seen, guys, what happens inside the firearm, let's move to and focus on what happens after the bullet hits its target. In forensic pathology, this area is crucial for reconstructing the shooting incident. This pathologist examines the trajectory of the projectile within the body, determining whether the wound is an entrance or an exit wound, and identifying which organs or structures were damaged. So terminal ballistics here allows experts to estimate the muzzle to target distance based on wound characteristics such as soot, deposition, burning, stippling, or tattooing. Each of these features reflects the energy, velocity, and proximity of the firearm at the time of discharge. This understanding here enables investigators to distinguish between close contact shots, intermediate range shots, and long distance discharges, which is an essential step in verifying statements or reconstructing events in both forensics and legal contexts. Now, guys, are you familiar to the typical categories of muzzle ranges?
No, ma'am. No, ma'am.
All right. Now we're going to dive into the categories of muzzle ranges, and this is very, very important in forensic ballistics. One of the key aspects, guys, of forensic firearm investigation is to identify the range of fire. In other words, the distance between the muzzle of the firearm and the target at the time the shot was fired. So this determination is primarily based on wound appearance and the presence of residues such as soot, which is the black one, the black color, or maybe unburned powder particles and skin tattooing. The typical categories of muzzle rangers are as follows. First, we have the close contact. So as you can see in the slide, the muzzle is pressed tightly against the skin or the cloth. So the gases here and the residues are driven directly into the wound, often causing tearing or blackening and a star-shaped entrance in the skin. So this is due to the expansion of gases beneath it. Okay? However, the loose contact, the muzzle is in light contact with the skin, allowing some gases to escape. You may still find soot deposition around the wound, but less tearing than in tight contact shot. Okay? Now, the near contact, as you can see, the muzzle here is highly away from the surface, usually within a few centimeters, so that soot and powder particles deposit around the wound in a concentrated pattern, as you can see in slide number 14. Intermediate range, typically this is within 1 meter, okay? So tattooing or stippling appears due to unburned or partially burned, sometimes powder, grains striking the skin. And sometimes, as a forensic ballistic expert, you won't be able to determine the range. So when no powder or soot is found and the wound lacks range-defining features, the shot is considered distant. So understanding these categories, guys, is really vital for reconstructing the circumstances of shooting incidents and verifying whether statements made by witnesses or suspects align with the physical evidence or doesn't or don't align. Moving forward, we're going to talk about bullet injuries now. We have, it's really important for you to know that when a bullet strikes the body, it transfers kinetic energy to tissues. So the degree of damage depends on several factors, including the velocity, the mass, the shape, and the stability of the bullet, as well as the tissue type it encounters. So if it hits a body, a human body, it's totally different than a wall or maybe a car, okay? So bullets can cause a variety of wound types, but fundamentally, we differentiate between penetrating injury, where you can find the bullet remaining lodged inside the body, and perforating injuries, where the bullet passes completely through and exits the body. Okay? The pattern of injury provides valuable information here. And these valuable information are about the weapon used, the range of fire, and the angle of impact. In forensic practice, the pathologist collaborates closely with the ballistic expert to correlate internal trajectories with external wound morphology, guys. And this ensures a complete reconstruction of the shooting event. Another type of bullet injuries, we have the perforating and the penetrating injury. Okay. Can you see slide number 17?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay,
Yes, ma'am.
thank you. So moving to slide number 17, we're going to talk about tangential and grazing injuries. Besides penetrating and perforating in wound or injuries, we can also observe, guys, tangential or grazing injuries, where the projectile strikes the body at a shallow angle instead of directly entering. So in these cases, the bullet scrapes or skims along the skin's surface, producing elongated, often superficial wounds, as you can see, and the direction of travel can frequently be determined by examining the abrasion pattern, which is deeper at the point of initial contact and shallower towards the end. So, as you can see, guys, here, when talking about tangential injuries, uh, you can analyze the position of the victim and the trajectory of the bullet at the moment of firing. So they can also indicate defensive movement or simply deflection of the projectile from another surface. So recognizing and interpreting these injuries require both medical expertise and a solid understanding of ballistics, as they often appear in complex shooting scenes with multiple possible angles of fire. Okay? Now we're going to talk about external ballistics. Just give me a second. Okay, guys. Can you see slide number 18?
Yes, ma'am.
Yes.
Okay. Well, okay. Now we're going to talk about external ballistics. So we're going to focus on the flight of the bullet after it leaves the muzzle and before it reaches its target. So guys, once the projectile exits the barrel, it's influenced by several external factors such as the air resistance, gravity, temperature, wind, humidity, and even the atmospheric pressure. In an ideal environment, a bullet would follow a perfectly straight path, but in reality, it follows a curved trajectory known as a parabolic path. So the bullet rises slightly above the line of sight due to the barrel's upward angle and then descends due to gravity. The spin of the bullet here, created by the rifling inside the barrel, provides stability, preventing tumbling and improving accuracy. So by understanding external ballistics is not just about physics here, okay? It's fundamental for reconstructing bullet path in crime scenes, determining shooting distances, and explaining why a bullet might deviate before striking the target. In forensic reconstructions, this knowledge allows us to calculate the trajectory and assess whether a projectile passed through intermediate barriers such as glass, metal, or walls before impact. So, we have now several defects like the penetrating, the perforating, the ricochet, or the tangential defect. Talking about the penetrating defect, the bullet enters and remains embedded in the object. However, perforating defects, the bullet passes through, leaving both an entry and exit hole. The ricochet or the deflection defects, the bullet strikes a hard surface and rebounds or changes direction. These often occur on floors, walls, or even metallic surfaces and can significantly alter the bullet's trajectory. And finally, the tangential defect result when the bullet grazes or skims a surface at a low angle, producing elongated marks similar to those observed in grazing injuries on the body. So the shape, depth, and directionality of these defects are crucial for determining the angle of impact and direction of fire, helping experts reconstruct the bullet's path within the scene. Now, do you know, guys, how we calculate the angle of impact? Have any idea about the calculation of the angle of impact?
No, ma'am.
No, ma'am.
Okay.
No, ma'am.
First, let's define the angle of impact. I want you to know that the angle of impact here describes the angle at which a projectile strikes a surface. This can help identify position.
Ma'am, your voice is breaking.
Play this eye. Yes, just a second. I'm facing some trouble. Okay, so can you see the screen now?
No, ma'am.
No, ma'am.
No, ma'am.
Okay, I will share it again. I'm so sorry, but I'm facing some connection trouble. Okay. Now, can you see it?
Yes, ma'am. Yes, ma'am.
Perfect. Okay. So we were talking about the angle of impact. So as you can see here, we have the width and the length. So all you have to do is to calculate the sine I. This is the angle I. This is the diameter of the bullet, okay? So let's say that this is A and this is B, okay? AB is equal to CD. Who can tell me why? So this line, which is AB, is equal to CD. Why, guys? Do you know? Because simply it's a rectangle. Okay? So sine I is equal to the width, which is DF, over LM. Okay? Once we calculate this angle, we can project backward to estimate the bullet's trajectory and identify finally the shooter's location. So by understanding this relationship, guys, this is really important, especially for court presentations. So when we visualize trajectories, this helps juries grasp the spatial dynamics of a shooting. Okay? So, and by calculating the sine I, we can say that I, which is the angle of impact here, is equal to LM over DF. So the inverse of sine I. Do you understand? Clear? Can you hear me, guys?
Yes, ma'am.
So is it clear for
Yes,
you,
ma'am.
or do you want me to repeat?
Ma'am, can you please repeat once?
Yes, for sure.
Yes, ma'am. Repeat once more again.
Yes, for sure. Okay, so I will repeat everything related to the angle of impact. We already defined or described the angle of impact, which is the angle at which a projectile strikes a surface, right? And this angle of impact can help identifying the shooter's possible position, which is relative to the target. In order to calculate the angle of impact, we should, as investigators, measure the length and the width of the bullet hole. This is the bullet hole. This is the bullet hole. Okay? Are you following?
Yes, ma'am.
Yes.
Right. So this is the bullet hole. So in order to calculate the angle of impact, we should measure the length and the width of the bullet hole, especially when it has struck a surface at an oblique angle, just like our case in the slide. The formula that you have to memorize is sine I is equal to AB over BC. Okay? And this is I. Guys, this is I, which is equal to this angle. Okay? Because they are adjacent. We have a side adjacent angle. This is mathematic. Okay? So sine I is equal to AB, the side opposite line AB, over BC. Okay? Now, how to calculate I itself? So the angle itself, the angle I is equal to the inverse sine function n, which is the inverse sine I. Do you copy?
Yes, ma'am.
Okay? So we have the major axis over the minor axis. This is sine I. Okay? And by calculating sine I, we can know the angle I itself, which is the inverse sine of n. Okay? Is it clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay, great. Now, moving forward, we're going to talk about the direction of travel of the projectile. So, by determining the direction of travel, guys, this is a very, very, very important key element in ballistic analysis, because the direction can often be deduced by observing the shape and characteristics of the bullet defect. Here, when a bullet passes through a surface, such as a wall, a car, a door, or even glass, the entry hole tends to be more sharply defined and smaller, while the exit hole is usually larger and more irregular due to the bullet's deformation and fragmentation. Okay? Additionally, microscopic examination of the surface can reveal secondary beveling, a pattern that indicates or include the side of the exit point. By mapping these features, guys, investigators can establish the bullet's line of travel, which determine its origin point and assess whether it passed through intermediate materials before striking the final target. As you can see here, we're going to talk about okay, just a second. Guys, can you see the slide?
Yes, ma'am.
I extremely apologize, but I don't know what's wrong today with the connection. Okay, so let's proceed. Oh my God. Okay. So can you see slide number 22?
Yes, ma'am.
Okay, let's proceed. Now we're going to talk about the entry and exit of a bullet defect in windshield glass. So as you can see in the slide, try to guess. In
Number 2 entry or number 1 exit, ma'am?
which one is the entry and which one is the exit? Try to
Number
guess.
2 entry, ma'am.
Okay, do you agree, guys?
Yes, ma'am.
Yes, ma'am.
Okay. Okay. It's really important that for you to know that one of the most illustrative examples of direction determination involves the glass. So when a bullet penetrates a glass surface, the resulting damage here pattern provides clear clues about the direction of the fire. So the entry defect on glass is generally smaller and neater, with a smooth outer surface and crater-like beveling on the opposite side. That is toward the direction of travel. The exit defect here, by contrast, is larger and more irregular, with a wide bevel facing outward. So, therefore, when examining two defects, let's say label A and B, we determine which side is the exit by observing where the glass has fractured outward. Okay? This simple yet powerful principle helps forensic investigators to identify which direction the bullet came from and reconstruct shooting events involving vehicles or even glass barriers. Okay, so as you can see, guys, one is smaller or larger than two. What do you think? In picture B,
Second one is larger.
I'm sorry, I couldn't hear you. Could you repeat?
Second one is the larger one.
Could you repeat, please?
And the
Second
larger
one is
one.
the larger.
Guys, can you hear me?
Yes,
Ma'am.
yes, ma'am.
So what were you saying, guys?
The first
We were
one is
saying
the
I can hear you. Please open your mic.
Ma'am, can you repeat your question, please?
Okay. In figure B, here. Okay, can you see the arrow?
Yes, ma'am.
Okay. Which one is the entry point and which one is exit defect? Here, in picture number B. What do you think, guys?
One is the entry point, ma'am, and second is the exit one.
One is the yes, is the ma'am.
Yes,
And second
ma'am,
is the
because one looks much smaller than second one.
Okay,
Ma'am, one is the
okay.
entry and
Very
second
good,
is the
very good, very good. Now, moving forward, we're going to talk about GSR, or the gunshot residue. The GSR, guys, is one of the most valuable forms of trace evidence, especially in firearm investigations. So when a firearm is discharged, guys, it produces a cloud of microscopic particles expelled from the barrel. So the breech and the other openings of the weapon, those create like this GSR. These tiny particles, often invisible to the naked eye, are collectively known as gunshot residue or GSR. So it's really important to know that the GSR is colorless and consists mainly of lead, barium, and antimony, all originating from the primer and the propellant materials. So these particles can adhere to the shooter's hands, face, clothing, and even nearby objects such as tables, vehicles, interiors, or walls. So the presence of the GSR does not always prove that a person fired a weapon, but it strongly suggests that they were in close proximity to a discharged firearm. This is why GSR analysis must always be interpreted in the context of other evidence. Okay? It's not sufficient alone. Now, talking about the chemical composition and characteristics of GSR, it's really important to know that the chemical composition and the morphology of GSR particles are essential for their identifications under laboratory examination. The GSR here typically contains compounds of lead stiffnate, barium nitrate, and antimony sulfide, which originate from the primer mixture. So during firing, these components, guys, partially vaporize and condense into microspherical particles, usually ranging from 1 to 10 micrometers in diameter. So under a scanning electron microscope equipped with energy dispersive X-ray analysis, these particles, guys, can be detected and identified based on their unique elemental signatures. In modern ammunition also, particularly lead-free primers, GSR may instead contain alternative elements such as titanium, zinc, or aluminium, making the interpretation more complex and emphasizing the importance of laboratory expertise. So, moving forward, and as you can see in slide number 24, we're going to talk about the methods of collecting GSR. Here, guys, collecting GSR properly is very critical and is really critical to ensure a very accurate analysis and avoiding contamination. So, the evidence collection should ideally be conducted as soon as possible after the shooting incidents because GSR can easily be lost through washing, wiping, or normal movement. The samples are typically taken from the hands of suspects, especially the back of the hand, the web between the thumb and the forefinger, and the palm. However, GSR may also be collected from clothing, the victim himself, or objects at the crime scene, like a car, table, or anything else. So the main collection methods include swabbing using a moistened cotton or an adhesive swabs. We have the adhesive stubs, which are small pieces, as you can see here. Okay, these are small pieces of tape designed to lift microscopic particles from the skin or fabric. And finally, we have the last method, which is using the vacuum collection. This is applicable only for larger surfaces when necessary. Each method has its own application depending on the surface and the type of analysis to be conducted. Okay? Now, I'm going to elaborate more the vacuum collection. This is a method, guys, typically reserved for large or irregular surfaces such as car interiors, walls, or seats. It involves also using a specialized vacuum device equipped with fine filter to trap GSR particles without cross-contamination. So this method is essential and very useful in cases where multiple shooters are suspected or when GSR may have settled on surrounding surfaces. However, due to the higher risk of collecting unrelated particles, this result obtained by vacuum sampling should always be interpreted with caution and supported by other forensic findings, because in all cases, meticulous documentation, labeling, and chain of custody are essential to maintain the evidentiary value of collected residues. Now, I want you to have a look on slide 26. What do you see here, guys? In slide number 26, what evidence do you see?
Ma'am, firearm cartridges, blood, biological evidence.
Very good. So we have a gun, we have cartridges, as you can see, and we have blood. Do you think these bullets were fired from the same firearm? What do you think?
Yes, ma'am.
Yes, ma'am.
So you all agree, guys, that these cartridges are fired from the same firearm.
Yes, ma'am.
Okay. Now we're going to talk how to investigate whether these cartridges are or belongs from to the same firearm or not.
What, ma'am? What you asked?
Yes, I can hear you.
Ma'am, what you have
Go
asked?
ahead.
Can you repeat once again?
I was asking, do you think these bullets or these cartridges were fired from the same firearm?
From different sides, ma'am.
Okay.
Yeah, ma'am, it will be concluded by using comparison microscope. Then only we can
Very
say.
good. Very good. Absolutely correct. Now we're going to dive into the comparison microscope, and we will be talking about how to compare these cartridges. Okay? But before talking about the comparison microscope, I want you to know that the packaging method when dealing with firearm is very, very, very crucial. We can use a cartoon bag or a plastic container. and you should, guys, be wearing gloves, okay? Now, after collecting the firearm and bullets or cartridges, and in order to determine whether the bullets were fired from the same weapon, the forensic ballistics expert performs test firing. So here, the firearm recovered from the crime scene is fired into a water recovery tank, ideally maintained at 26 degrees, to prevent ricochet effect and minimize the bullet deformation upon impact. Okay. After the shooting, now we have to compare the bullet which was found at the crime scene, or the cartridge found at the crime scene, relatively with the bullet that the forensic expert already fired. Okay, so the comparison microscope is a device that we use in forensic ballistics in order to compare two bullets or two cartridges, and they are viewed simultaneously side by side under magnification. When a bullet is fired, the microscopic irregularities inside the barrel caused by rifling and manufacturing imperfections, this leave unique striations on the bullet's surface. Similarly, the breech face, firing pin, and extractor leave characteristic mark on cartridge's case. So, have a look on the cartridge case marks. We have the ejector mark. Okay, these marks appear clearly under the comparison microscope. We have the tongue mark. We have the firing pin impression, as you can see here. Okay, we have the breech face mark. This is a very strong imprint. We have the primer, as you can see here. This is the ring, okay, the rim. We have the ejector mark, okay. So these marks will be shown under the comparison microscope, sorry. So forensic examiners here, guys, compare these microscopic impressions from an evidence bullet with those from a test-fired bullet recovered from the suspect weapon. So if the individual characteristics match, such as striation patterns, groove width, and firing pin impressions, the examiner can state with confidence that both bullets were fired from the same firearm. This technique is not just about observation, it's about pattern recognition, guys, meticulous documentation, and scientific verification, forming the backbone of firearm identification worldwide. Okay? Have a look. We have the breech block imprint, as you can see here. We have the primer pin, the pin imprint here. So the hole in the center, as you can see, is the imprint from the primer pin or the firing pin. However, the striation within the circle are breech block impression, guys, here. I have more image. Well, that's a very good photo. Okay. If you see this, these are the striation. I'll change the color. Okay. So these are the striation, guys. They are a very fine lines which help in investigating or testing and knowing whether these bullets refer from the same gun. Okay? So, and we have this line that separates both bullets under the microscope. Okay? Here another example. We have this line, as you can see. Okay. And we have those or these striation. See, they are the very fine line that we can compare under the comparison microscope. Okay? Another example here. This is the firing pin impression. See? This is the line which separates both cartridges. Okay? So we have a big match here. Look, guys. We have a big match here. Can you see that? Is it clear? Is it clear for you?
Yes, ma'am.
Yes,
Perfect.
ma'am.
Yes, ma'am. Yes, ma'am.
Perfect. So we have also the breech face marks, also the striation at the level of the breech face mark. See, this is again the line which separate two bullets or two cartridges here under the microscope, under the comparison microscope. And we have these striations on the cartridges. See, we have also a big match. A very good one here. It appears clearly, guys. Okay. We talked about the imprint left on the cartridge. Now we're going to talk about the bullet marks. We're going to talk about the lands and the grooves. Okay, so as you can see here, this is a land, this is a groove, and so on. We have the striations left on the bullet itself, like here. Okay, those are striations. And we're going to check also the deformation, if there is any deformity or any deformation generally. Okay? Okay. So, to match bullets to a gun, guys, we're going to test them under the comparison microscope. So we'll examine the bullets side by side to match the striation here. Again, here we're trying to match the striation. See the very fine line on both bullets? Okay, and this is the line which separates both bullets. Okay? Voila. Have a look on this slide. Do you think it's a good match?
Yes, ma'am. Yes, ma'am.
Very good. Very good. That's a very clear match. Okay? Well, this is another example. We have a match here, but here we don't have any match. There's no match. Now, let's proceed. We're going to talk about the serial number restoration. Guys, it's really important to know that firearms are typically marked with a serial number by the manufacturer or identify and trace each weapon. However, in criminal cases, and this is very common, it's very common to encounter firearms where these numbers have been intentionally filled off to prevent identification. So the process of serial number restoration enables forensic experts to recover these erased marking using chemical products or chemical substances. And sometimes we use physical substances or even magnetic techniques. When a number is stamped into metal, like as you can see here, it causes plastic deformation that extends below the visible surface. Even if the surface is later filled down, these subsurface distortion remain and can revealed using appropriate reagents. And we're going to talk about the reagents. And this procedure, guys, allows forensic scientists to link a weapon to its manufacturer, owner, or even country of origin, often becoming a critical piece of investigative evidence. So, we have two types here. We have the steel and we have the aluminum sample. For steel samples, several chemical reagents can be used depending on the metal type and surface condition. The most common solution include Oiseau, Fry, Attieh, and Soot. The process begins by dipping a cotton-tipped applicator in Oiseau solution and gently applying it over the area where the serial number was removed. So, as the solution here reacts with the metal, the engraved characters gradually begin to reappear. If the characters are faint, fried solution may be used to enhance contrast, and for corrosion resistance or stainless steels, MIPRO solution may produce better results. The surface here is continuously monitored throughout the reaction. If you wish to stop the process temporarily to examine the progress or take photographs, simply wipe the area with acetone to neutralize the reagent. Once the serial number is clearly visible, as you can see here, guys, the surface is cleaned again with acetone to preserve the restored markings for documentation and photographic evidence. This technique demonstrates the delicate balance between chemistry and investigative precision that defines modern forensic science. Okay? Now, when dealing with aluminum firearms or components, different chemical reactions are required because aluminum, guys, behaves differently from steel. In this case, we use 10% sodium hydroxide solution on a cotton applicator, and we can apply it to the surface until the hidden serial number begins to appear. Alternatively, we have the Oiseau solution can also be used, but care must be taken to prevent over darkening of the surface. Okay, because it really darkens the surface, especially when we have aluminum sample. If this occurs, a small amount of pure nitric acid can be applied to lighten the metal, guys. Now, if you want to enhance the visibility, sometimes we can use fried solution, which enhances the engraved characters. And additionally, we have the nitric acid, which clears the surrounding metal. So continuous observation is very essential here. As soon as the characters become legible, the reaction should be stopped and the area cleaned with acetone. This procedure highlights the precision and patience required in forensic metallurgy, where even the faintest impression can lead to the positive identification of a weapon, guys. Okay? Now we're going to talk about the origin of the gun or the country codes. Once the firearm serial number is visible, we can often determine its country of origin based on standard manufacturer codes. These are international codes, guys. So each country or manufacturer is typically identified by a two-letter code. So, for example, as you can see, UK or VJ indicates the United Kingdom. We have US or USA represents the United States. AT for Austria, FR for France, DE for Germany. We have, for example, CN for China, RU for Russia, PK for Pakistan, and so forth. So, by understanding these codes, allows investigators to trace the weapons across borders, a process that can reveal smuggling routes, black market connections, or simply military transfers. This international tracing process is often done in collaboration with agencies, guys, such as Interpol, Europol, or national ballistics databases, reinforcing how forensic science plays a key role in global crime control. Okay? Here, an example. We have, guys, symbols or even like stamp that determines the origin of a gun. So here we have like Poland, it's 11. We have 25, 21, or 10, Bulgaria, and so on. So we have different symbols or different signs in which you can know and notice which origin of a gun, which country produces or manufactured this gun. Okay, who can tell me DE refers to which country? We already mentioned this, guys.
Germany.
Very good. Very good. Exactly. What do you think about this one, guys?
Russia.
Great. And this one? Look, it's here. It's also Russia. Okay? It's the same symbol. Clear? But 66 doesn't refer to Russia. It refers to China. Okay? You can have these symbols, guys. You can find them. Questions till now? All right. Now, moving to our last slide, we're going to talk about the serial. We're going to discover the date through the serial number. Okay? So, as you can see, we have an example here. Let's say this is our serial number. Okay? We should divide it into 3 segments of 1000 as follows. So it becomes 2.432.30. Then the first number from the left side is 2, right? And the manufacturing data or date would be 1958. How? We're going to talk about it. Internationally, 1 refers to 1957, 2 refers to 1958, 3 to 1959, 4 to 1960, 5 to 1961, 6 to 1962, and so on. So when you divide the serial number into segment of 1000, all you have to do is to look or have a look on the number located on the left side, okay, here, which is number 2. So 2 means 1958. And this is how, guys, you will be able to discover the date through the serial number. Any questions till now? Well, as we conclude this session, I would like to take a moment to thank each one of you for attending today's webinar. And I'd like to thank Forensic Fusion team, Mr. Swapnil, for inviting me and for having me. Besides, I'd like to emphasize the skills discussed today. Guys, they are not merely theoretical. They have direct applications in forensic investigations, quality control, and regulatory compliance. Thank you so much for attending and for your active participation. The knowledge you have gained today will enhance your analytical precision and strengthen your investigative capabilities. I encourage you guys to apply these techniques in your professional practice and continue exploring manufacturer documentation for deeper insights. And I look forward to share more knowledge about ballistics and forensic field. Thank you once again. Now I'll keep. I will open the floor to Mr. Swapnil.
Thank you,
Thank you
ma'am.
so much, ma'am. Thank you so much, ma'am. Am I audible, everyone?
Yes, sir.
Yes, sir.
Okay. So
Yes, sir.
before we move forward, I would just like to make a small announcement, guys. So for today's session, we will not be having any kinds of assignments because I can totally understand you have already had 4 assignments, right, previously. So moving forward with tomorrow's session, you will be having assignments. Is that clear?
Yes, sir. Yes, sir.
Yes, sir.
Great.
So,
So meanwhile, please ensure that all your previous assignments are submitted to the Veritas Vanguard 1.2 at the rate gmail.com. Okay,
Sir.
great. So as we conclude the session, I would like to thank Miss Yoanna. That was truly a captivating session. Forensic ballistics is truly often made to look simple in movies, but today you showed us the real scientific depth behind it.
Thank
From
you.
station matching to understanding wound ballistics. We are incredibly grateful to you for joining us from Lebanon and bridging the distance to share your knowledge. Your experience with the military police laboratory really brought a unique practical perspective that textbooks simply cannot offer. Thank you for being a part of the Veritas Vanguard and for inspiring our interns to look at firearm evidences with a sharper and more analytical eye. To all our participants, we will be going to see you all in next session, that is tomorrow. Let's keep this momentum going. All the very best, guys. Keep learning. Bye bye.
It's
Thank you,
such a
ma'am.
pleasure to meet you all. And thank you once again for having me. Have a good evening.
Thank you,
Thank you,
ma'am.
sir.
Have a great evening ahead.
Thank you, ma'am.
thank you,
Okay, ma'am.
ma'am.